I was sitting on a park bench when I got to thinking about how I could determine an approximation of the height of the building by using the properties of similar triangles. So I pulled out some digital calipers and did a measurement of 0.295 feet or 90 millimeters from a distance of 1.67 feet or 0.508 meters from the calipers to my eye. I looked up my distance on Google from my location to the base of the building and got a total distance of 2,212 feet or 674.2 meters. Now I've given you all of the givens. Pause here and see if you can figure out how to solve this problem. Now the property of similar triangles indicates that if you have two triangles with the same angles, the ratio of the side lengths to one another are equal to one another. So h1 divided by l1 is equal to h2 divided by l2. The ratios of the sides are equal. So in this case, the caliper measure height of the building divided by the distance to the calipers from my eye is equal to the actual height of the building divided by the distance to that building. Once again, this only works if you are working with triangles that have the same angles when compared. Now, rearranging this formula, we get that the height from the calipers divided by the distance to the calipers from my eye times the distance from my location to the building is equal to the height of the building, which ends up equaling 391.9 feet or 119.5 meters. According to Google, this building has a height of 400 feet or 121.9 meters. This leaves us with a 2% error. This video is intended to show how to give an approximation of the height using the properties of similar triangles. That concludes this video. You can make me feel like less of a crazy person for sitting on a park bench with calipers at arm length measuring buildings if you give me a like, share, or subscription. Thank you for watching.